Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math problems out of this book here, the official guide to the GRE, the revised journal test. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 297, and today is our lesson number 192. Problem number 9 on page 297, please turn to it. It says, in problem number 9, it says, from a box full of 10 light bulbs, you are to remove 4. From a box full of 10 light bulbs, we are to choose 4. And the question simply is, how many different ways, how many different sets of 4 light bulbs can be chosen? Now listen, before we do this problem, which is called 10 choose 4, before we do 10 choose 4, which is a bit more complicated, before we get to that thing, let's keep it in abeyance, let's keep it aside, let's put it aside, and we'll deal with it later. That's what abeyance means. If you want to learn the meaning of the word properly, type in vocabulary day 9, put in my name, Keshwani, and then vocabulary day 9, and you will learn the word abeyance. I use that all the time. Learn it, it's a good word to know for the GRE. Before we deal with this something as complicated as that, let's deal with something simple first. We're going to leave that question in abeyance right now. Let's start with something simple. Let's start with 3 choose 2. So we have 3 objects or 3 people or 3 whatever, and we are asked to choose 2 of them. The difference between the notion of permutation, which is what we are going to learn today, the difference between the notion of permutation and a combination is a fundamental one. And the difference is that in permutation, order matters. Order matters. In which order you pick things, it matters. In combination, it does not mean, which is why it's called combination. You just combine them. It doesn't matter. Once you have combined them, that's it. For example, here, how many different ways can we pick a first person? Since there are 3 of them, we can choose the first person in 3 different ways, either A, B, or C, right there. Once we have chosen the first person, how many different ways can we pick a second person? Or the remaining, well, there are 2 people remaining. Once we have chosen one person, we have 3 to start out with. Once we have chosen one person, there are only 2 remaining. So there are 2 different ways of choosing a second person. So if we choose A the first time around, for the second spot, you see second spot, the spots have significance. For the second spot, we can either choose B or C. If we pick B for the first spot, then we can choose either A or C. If we pick C for the first spot, for the second spot, we can choose either A or B. There are 6 different ways. And all of these different ways of putting them together, I was about to use the word combining them together, but no, the word combination has a very special meaning for mathematicians. They do not use the word combination and putting them together, and they don't use the term combination so loosely. For them, the word combination has a very special meaning. It is a jargon in mathematics. Combination to a mathematician is situations where order does not matter. For example, here, watch what happens. We're going to do the same. We're going to do the same exercise, same exact exercise. A, B, C. If we picked A for the first spot, we can have either B or C. If we pick B for the first spot, we can have either A or C. If we pick C for the first spot, you can have either A or B. Then what we notice is that once we have chosen A and B, we cannot go around going B and A. That will not count. You see, there is a repetition. A, B, and B, A. There is a repetition here. That won't do it. That won't do. Similarly, here we have A, C, and we have C, A. That won't do at all. That won't do at all. Then we have B, C, and we have C, B. As you can see, everything is repeated. Since everything is repeated, therefore, however many ways there are of choosing a first person times however many ways there are of choosing a second person, listen very carefully, we take the product of those 2 and we take half of that quantity. So here, there are 3 ways of choosing a first person, there are 2 ways of choosing a second person, and we take half of it. Take half of it. So 3 times 2 times half, which is same as 3 times 2 over 2, and 2 cancels out, and the answer is 3. There are 3 ways of choosing 2 people out of 3. There are 3 ways of choosing 2 people out of 3. I did not leave any room for myself. I should have, but I'm going to squeeze it down here. I hope you can read it. Or better yet, I can erase this part here, and I can just make a note here that this equals 3. And there are 3 ways of choosing 2 people out of 3 when the order does not matter. Here are the 3 ways: A, B, C. You can either choose A and B, that's one way, A and B, or we can choose A and C, that's another way, or we can choose B and C. That's the third way. That's the second way. That's the first way. B and C. Having chosen B and C, we are not at liberty to choose C and B as another arrangement. Order does not matter. It doesn't matter whether you choose B first and then C, or vice versa. It doesn't matter whether you choose A first and then B, or vice versa. So there are only 3 ways. There are only 3 ways. Now the thing would not have changed anything. It would not have changed anything except the higher the numbers, the more tedious it is to actually do it out like this. So I'm not going to do it actually, but I'm just going to show it to you. Nothing would have changed. Let's erase this part because I'm going to do something more complicated now. What if we had 5 people? 5 choose 2. Well, it will be the same thing. There will be 5 ways. There will be 5 ways to choose first person. Once we have chosen one person out of 5, how many people are left? There are 4 people left. There will be 4 ways of choosing a second person. But then we realize that every time we pick a second person, everything is double counted. A, B, B, A, A, D, D, A, E, E, A. You get the idea. B, C, 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 B. Everything is double counted. Therefore, whatever this product is, we got to take half of it. We have to take half of it. And therefore, in this case, the answer would be 5 times 4, and then you take a half of it, which is same as dividing by 2. Nothing would have changed. Nothing would have changed. If you had 15 people and if you're asked to choose 2, then it would be simply be 15 times 14. There are 15 ways to choose a first person, 14 ways to put a second person out of 15 people, and you take that quantity. That would have been the answer if we were doing permutation. Because in permutation, the repetitions are allowed. Order matters. In permutation, order matters. Here, order matters. Order matters. Here it does not. Since the order does not matter, whatever that product is, we got to take half of it. Now let's go to something a little bit more complicated. Let's go to something more complicated. I keep picking up these black markers and I keep throwing them away because for some strange and inexplicable reason, they have all decided to die at the same time. I'm beginning to suspect that it might be some sort of a cult. Alright, let's do something a little bit more complicated now, a little bit more interesting. 3, we have 3, and let's choose 3. 3, choose 3. How many different ways we can pick a first person? 3 different ways. A, B, and C. 3 different ways we can pick a first person. How many different ways we can pick a second person? Well, obviously 2 different ways because there are 2 people left. Same as before, B, C. If you pick B, it will be A, C. If you pick C for the first spot, it will be B, C. How many different ways we can pick a third spot? Third spot, we can have only one person. Only one choice. Why only one choice? Because there were 3 people to begin with. So therefore we had 3 choices to pick the first person. Once we have chosen one person, we only have 2 choices to pick a second person. Once we have chosen a second person, then the third spot here is not a matter of choice because whoever is left is going to be the third one picked. And of course the order matters here. Here, in which order we pick them has a big significance. So if you're talking about what are the odds, think of this as first position, second position, and third position, or the chairs being numbered. Well, there are how many different ways of arranging 3 people in 3 chairs if the chairs have significance, if they are numbered. Well, for the last one we only have one choice, which is if it's AB, then we can have C. If it's AC, we can have B. If it's BA, we can have C. If it's BC, we can have A. If CB, if we can have A. And then of course if it's CA, we can have B. If I made a mistake, don't worry about it. I think I made a mistake somewhere. Okay? So there are 6 different ways. There are 6 different ways. There are 6 different ways of choosing 3 people out of 3. You see? Keep listening. As I said, 3 ways to choose first person. There are 2 ways to choose second person. And finally, there is 1 way to choose the third person. There are 3 times 2 times 1, 6 ways. Now let's talk about combination. Let's talk about combination. How many ways do you suppose there are of picking 3 people out of 3 if the order has no significance at all? In combination, order does not matter. Order does not matter. If order does not matter, then how many different ways can you pick 3 people out of 3? But there's only 1 way. There's only 3 people. You just pick all 3 of them. That's it. You're done. There is only 1 way. It's not a matter of choice. That's all it is. But we're going to show it mathematically so that we understand the concept, so that when we deal with the bigger number, we would know what to do with it. Here it's a simple case because we already know the answer. There's only 1 way. But then what happens if there were 8 people and we were asked to choose 3? That's what we want to understand. So we already know. So here we go. We already know that there are 3 ways of choosing 2 people. 3 ways of choosing 2 people. And here are the 3 ways. One more time. A, B, C. You can have A, B, you can have AC, or you can have BC. And that came from the fact that there were 3 ways to choose the first person. There were 2 ways to choose the second person, and then we take a half of that times half. Why take half of it? Because everything is being repeated, so we have to divide the whole thing by 2. Once we have chosen the 2 people, let's choose the third person. Once we have chosen 2 people, let's choose the third person, and we'll see what happens. Okay? So here are the combinations. Here are the 3 combinations of picking 2 people: AB, AC, or BC. Think of them as blocks. 2 people have already been chosen. 2 people have already been chosen. The question is, how many different ways I can pick a third person? But there are 3 different ways of picking a third person. I can either have a C, or I can either have a B, or I can have A. There are 3 different ways of choosing third person. But then what is going on? What is going on here? Everything is being counted 3 times. It's being counted 3 times. ABC is counted as 1 way, ACB is counted another way, BCA is counted another way. Everything is counted 3 times. So by the time you pick a third person, whatever that number that you arrive at, you got to take that number of combination, or rather number of arrangement. Don't use the word combination in this case. Combination, the word combination has a very specific meaning, very special meaning in mathematics, in statistics. So however many arrangement that you found to pick 3 people, a third person rather, however many ways you found to pick third person, you got to take a third of it. You got to take a third of it, because everything is being repeated. Everything is being counted 3rd time. So for the 2 spots, this is how many ways we found. For the 2 spots, this is how many ways we found. There were 3 ways. There were 3 ways to pick a first person. There were 2 ways to pick a second person, and then we take half of it. We take a half of it because everything is being repeated. And now here there are 3 ways of picking a third spot, and because everything is being counted 3 times, everything is counted 3 times, because basically it's the same thing. So what does it boil down to? it boils down to, watch what happens. 2 is cancelled out, you will 2, and 3s are going to cancel out, and I made a slight mistake here. There are not 3 ways of picking a third person. There are another 3 ways of picking a third person. There is only one way, okay? There is only one way of picking a third person. You can clearly see once A and B is chosen, there is only one way to pick a third person, because whoever is left is the one that's going to be picked. There is only one way to pick third person. And what happens is that when we pick the third person, we realize that everything is being counted 3 times. So therefore, since everything is counted 3 times, we got to take the third of it. We got to take a third of it. And now this 3 is going to cancel out with that 3, and we're going to end up with just 1. Which makes perfect sense, because we already know that if there are 3 people and we are asked to pick 3 people, there is only one way to pick the 3 people out of 3, which is just to pick all 3 of them. Now let's ask ourselves something more complicated. Let's do this thing. Now let's do 6 choose 3, and you will see the difference here. 6 choose 3. How many different ways we can pick a first person? There are 6 ways of picking a first person. How many different ways can we pick a second person? Well, since there are 6 people, I still have 5 choices to pick a second person. But then I realized that when I choose when I put down there are 6 ways to pick a first person and there are 5 ways to pick a second person, that pairs are going to begin to repeat. A, B, B, C, A, E, A, D, C, C, D. Everything is going to be counted twice. And since here order does not matter in the pair, I have to take that quantity and divide that by 2. How many different ways can we pick a third person? Well, there were 6 ways to pick a first person. There were 5 left for the second spot, so there were 5 choices to pick a second person. Once we have chosen a second person, how many different ways do we have to pick a third person? The answer is 4, because there are still 4 more people left once we have chosen 2 out of 6. So there are 4 ways to pick a third person. But then we should immediately realize that as soon as you start picking a third person, everything begins to be counted 3 times. ABC counts as 1, BCA counts as 1, and CAB counts as 1. As you can clearly see here, ABC counts as 1, ACB counts as 1, and BCA counts as 1. We can't have that. We cannot have that. Order does not matter. So however the quantity is here, we got to take a third of it. We have to take a third of it. And therefore the final answer is 6 times 5 times 4 over 2 times 3. Let's do one more. Let's do one more. Let's choose 8. Let's choose 8 out of 3. Okay, let's choose 8 out of 3. So 8 out of 3, there are 8 ways to pick a first guy, 7 ways to pick a second guy. And since everything is being repeated, we got to take a half of it. Now there are 6 different ways of picking a third guy. And since everything is being triple counted, we have to divide that by third. So finally what we end up is 8 times 7 times 6 over 2 times 3. And 2 and 3 cancel out with 6. And we end up with 8, 7, 7 sevens are 49, 49 plus 1 more 7 is going to make 56. Voila. So this is the answer to 8 choose 3. 8 choose 3. This one, that we just did, this problem that we just did, 8 choose 3, is the exact same problem. Is the exact same problem as problem number 7 on page 157. Problem number 7 on page 157 is the exact same problem. If you turn to page 157, please turn to page 157, and you will see that in that on page 157 we are told that we are forming a committee. Give me a second here. We are forming a committee out of 11 people. Out of 11 people, but then they go on to tell us that 3 of those people have already been chosen. If 3 of the people have already been chosen, the question is how many ways there are for me to complete my committed, which is same as asking, since 3 of them are already chosen out of 8, which means we have to choose 3 more out of the if 3 of them are already chosen out of 11, a total of 11 people, if 3 of them are already chosen, this is basically essentially same as asking how many different ways are there of picking 3 more people out of 8, which is exactly what we just did here. You understand? This is, if you want to watch this thing, the very first time that I did, I spent a lot of time on it. Even right now it's taking a lot of time, but that's okay. And it was done on, just give me 1 second, I'll have it written down somewhere. Day 57 and 58. Day 57 and 58. So if you want even more detailed explanation, because if you're still confused a little bit about it, if you want to understand it even better, instead of simply memorizing the formula, a lot of the time teachers simply throw off this formula which is so alien and so annoying, and you have to remember it. A lot of the times you misremember things and so forth. Don't do that. Just understand the concept. If you want to understand the concept without having to memorize the formula, it will take an investment on your part of 1 hour. It will take an investment of 1 hour from you to understand it thoroughly, in addition to what you have watched so far, because that's how long it's going to take you to watch these 2 days. Day 57 and day 58, they were both half-hour long video. So anyway, that's that. Now let's do the problem that they give us. Now that we understand the concept, thoroughly, you will see that the problem that they give us there is a very simple problem. Very, very simple problem. The problem is this: 10 choose 4. Well, that's so simple. 10 choose 4. How many different ways can I pick a first bulb? 10 ways. And bulbs have no significance. Bulbs are not number. A bulb is just a bulb. So there are 10 ways I can pick first bulb. There are 9 ways I can pick a second bulb. Is that what you think? 10 choose 4? That's right. There are 8 different ways I can choose the third bulb. There are 7 different ways I can pick the fourth bulb. But then when I realized that when I pick the first bulb, everything is being double counted, so I have to take half of that. By the time I pick the third bulb, everything is being counted 3 times, I got to take a third of that. By the time I choose the fourth bulb, everything is going to be counted 4 times, so I have to take a 4 of that. This is essentially 10 times 9 times 8 times 7 divided by 2 times 3 times 4. Now mathematicians have a very fancy name for it. We're not going to worry about it. We're not going to bother with it. They use very complicated symbols, fancy formulas and fancy symbols and all that. We're not going to do that. Just understand the concept and get the job done. That's what I want from you. Understand the concept and get the job done. Okay, we're not going to turn this into a freak show. So let's do that. 2 times 4 is 8, which is same as this guy. Let's divide top and bottom by 3, so get rid of this 3 and this 3 becomes 3. So essentially we have 10 times 3, which is 30, times 7 right here. So it's 30 times 7, 3 times 7 is 21, so it's just 210 ways. There are 210 ways of choosing 4 bulbs out of 10. I'm just going to turn the page and confirm my answer before I wrap up the video. This was problem number 9, was it? Problem number 9, 210 ways. Do you understand? One more time, it's very simple, very straightforward. Since there are 10 bulbs to choose from, there are 10 different ways we can choose the first bulb. There are 9 different ways we can choose the second bulb. So this is how many ways do we have? 90 different ways of choosing 2 bulbs out of 10 if repetitions were allowed, if bulbs were somehow numbered, and if there was any significance of choosing bulb number 1 first and then the bulb number 2 second, or choosing bulb number 2 first and then choosing bulb number 1 second. There is no such thing here. Bulbs are not numbered. The bulb is a bulb. Everything is uniform. So the repetition is not allowed. This is not a permutation. This is a combination question. This is a combination question. This is all combination. We are doing combination here. The entire question, question number 9, is about combination. That's the heading I'm going to. That's the tag I'm going to put in the video. It's a combination, not a permutation. So once you have chosen the second bulb, there are 90 ways. We take half of it because everything is being repeated. How many different ways we can choose a third bulb? 8 different ways. But as soon as we begin to pick a third bulb, everything is being repeated 3 times. Well, not everything is being repeated twice, and therefore everything is counted 3 times. And therefore you take divide by 3. And finally, how many different ways of choosing a fourth bulb? The answer is 7. And since everything is counted 4 times, you got to take a fourth of that. And that's what it boils down to. Alright, I will see you tomorrow. And hopefully you will begin to understand this concept. Now there are many new topics that are covered in the new GRE that simply did not exist in the old GRE. This is one of their new ones here, the permutation and combinations. And in the geometry they have introduced this concept of graphs of circle and parabolas and what they call piecewise functions. All of these things didn't exist before. And in statistics they have introduced many different concepts like normal distribution, and it's much more complicated now than it used to be before. This thing didn't exist before at all. Never had to talk about it before. Which is why I take my time to explain this thoroughly, because it's difficult to find practice questions for it, because in the old GRE you will not find them because they didn't exist. I'll see you tomorrow. Okay? Bye.